Welcome to this explainer. Okay, let's dive right into this. Today, we're doing a formal technical briefing on the Arianna software ecosystem. Imagine you're trying to coordinate a tactical team deep underground, or maybe in a dense, multi-level urban structure. Satellite signals? Yeah, they simply can't reach you there. And the stakes in these environments are usually life or death, so absolute spatial awareness is completely non-negotiable. To solve this pretty massive operational challenge, we're going to look closely at a specialized suite that's designed specifically to track personnel with pinpoint accuracy when GPS fails, is jammed, or is just flat out unavailable.
So here's our quick roadmap for today. We'll be looking at 1. Tracking without GPS. 2. The Arianna hardware foundation. 3. The software ecosystem. 4. Arianna map real-time tracking. 5. Arianna 3D map advanced visualization. And finally, 6. Delivering tactical awareness. Let's get to it.
Section 1. Tracking without GPS, the operational baseline. Now, the foundational solution here is an inertial navigation system, or INS. But what makes the Arianna INS uniquely powerful is how adaptable it is. By default, an INS is completely autonomous. It's just churning out a relative path based purely on how the operator physically moves. But this system lets you easily transform that relative movement into an absolute position. We're talking exact latitude, longitude, and altitude. You just use a last known initial GPS fix right before they enter the denied area, or honestly, you can just manually click a starting point on a digital map. And here's the really cool part. If an incident commander updates that starting point on the map in real time, the system automatically recalculates the entire historical track and shifts it to the correct absolute path. It's a total game changer.
Moving on to Section 2, Arianna Hardware Foundation, Data Generation. So, before the software can do any of that dynamic mapping magic, we obviously need to generate the raw inertial telemetry, right? Let's briefly look at the physical gear. This hardware baseline is what makes infrastructure-free tracking possible, and it relies on two main pieces. First up is the smart sensor. This is a tiny, lightweight unit secured right onto the operator's boot. You can use laces, straps, clamps, whatever works, and it physically logs the pure movement data. Second is the master control unit, or MCU, which is worn right on the belt. The MCU holds the battery, processes that raw sensor data, and handles the wireless transmission to beam that telemetry back to command. The best part? No pre-deployed beacons required. The operator is literally carrying everything they need.
All right, Section 3, the software ecosystem, core architecture. So, while the hardware is out there generating the raw telemetry, the real operational value gets unlocked by how that data is actually interpreted. The crucial point here is the software ecosystem, so let's shift entirely to the architecture processing these inputs. The Arianna software family gives us a really nice breadth of applications adapted for different operational scenarios. Right at the core, you've got Arianna Map. That's your primary PC interface for real-time 2.5D tracking and receiving data. For a deeper, more spatial look, there's Arianna 3D Map, which is specifically for three-dimensional visual rendering on map tiles. Then we have Arianna SRV. Think of this as your headless backend application. It's purely focused on collecting data and processing algorithms to integrate into other systems. And finally, Arianna App, which is an Android smartphone companion. This lets an individual user see their own track locally or relay that data remotely back to the commander.
Now, driving all these different programs is one absolutely vital engine, the Arianna DLL. This dynamic link library packs a really robust stack of algorithms. See, when you're dealing with purely inertial tracking over a long mission, even tiny mathematical errors can compound into some pretty serious spatial drift. I mean, an operator might look like they're in a hallway when they're actually a whole block away. To stop that from happening, the Arianna DLL automatically applies the algorithms you see here, things like user correction, magnetic correction, map matching, to mathematically tighten up and improve the track quality on the fly. A commander can even pick and choose which algorithms to apply based on specific environmental variables. It basically ensures absolute precision when it literally matters the most.
Section 4. Arianna Map, real-time tracking and 2.5D visualization.
Let's zoom in on the primary command interface used during live ops. This standalone application is designed to track a team of up to 5 users all at the same time. Looking at the interface, you can see the red line tracing the absolute path of an operator over a 2D map layer. But we all know that in a complex urban environment, a flat coordinate is just half the battle. You really need to know what floor they're on, right? Well, notice the time versus elevation graph sitting right above the map. This brilliantly illustrates one of the system's most powerful features. It gives you a synchronized real-time altitude profile, so you can confirm exactly when an operator is climbing up a stairwell or heading down into a subterranean level.
Having that vertical awareness, it is absolutely vital for tactical command.
Now, to really grasp how flexible this ecosystem is, let's contrast Arianna Map with Arianna Serve. Arianna Map is your all-in-one, out-of-the-box solution. It comes with a built-in UI, gives you that live 2.5D tracking, hands you direct control over the DLL algorithms, and can even act as a TCP/IP repeater to push data to a secondary command post. Arianna Serve, on the other hand, is completely headless, no user interface whatsoever. It's meant to sit quietly in the background, collect the data, process the algorithmic corrections, and just feed those perfected tracks straight into your organization's custom GIS software or proprietary command dashboard. So in short, Arianna Map is your immediate tactical screen, while Arianna Serve is the silent engine plugging right into your existing infrastructure.
Which brings us to Section 5, Arianna 3D Map, Advanced Spatial Visualization. Let's move to the next layer and see how this builds into an even more advanced visual awareness.
Okay, so a 2D map with an elevation graph is highly effective, for sure. But some incident environments are so complex, they demand true three-dimensional context. That's where Arianna 3D Map comes in. It acts as a dedicated 3D viewer, rendering the tracking data inside a fully rotatable 3D space layered right over map tiles. Just imagine trying to manage a response in a dense, multi-tiered place, like a subway station or a skyscraper. Having this kind of visual spatial tracking drastically cuts down on confusion and really speeds up tactical coordination. The incident commander can spin the view, zoom in, and instantly grasp exactly how the team is dispersed across vertical space. It's pretty incredible to see in action.
Finally, Section 6, Delivering Tactical Awareness, System Integration.
Let's tie it all together and map out the complete data lifecycle during a live deployment. Step 1. The operator moves, and that boot-mounted smart sensor precisely logs the raw inertial data. Step 2. The MCU on their belt immediately takes that data and blasts it out over an available radio or wireless link. Step 3. The data hits the command center, where the Arianna software ecosystem instantly applies those critical DLL algorithms to clean up and stabilize the path. And finally, Step 4. The fully corrected absolute path shows up seamlessly on the commander screen. What you get is an uninterrupted, completely infrastructure-free loop of critical intelligence. It's delivering actionable data exactly when you need it, in real time.
We've seen how this entire ecosystem provides rigorous, real-time spatial data, and it does it without relying on vulnerable satellite networks or having to pre-deploy a bunch of beacons. So I'm going to leave you with this final thought. How will autonomous, infrastructure-free tracking fundamentally reshape your own incident command and response protocols? Because having guaranteed visibility of your personnel in the absolute most challenging, disconnected environments, that isn't just a minor operational upgrade. It is a complete paradigm shift in personnel safety and tactical execution. Thanks for joining me for this explainer, and I'll catch you next time.